Now we will practice setting up real-life problems that can be modeled with sine and cosine. The table shows the depths in feet of water at the end of a dock at various times during the morning, where t equals 0 corresponds to midnight. We want to first use a trig function to model the data. So I was nice here and included a plot of this data already. We can see that the water goes up, water level goes up and down and up as the tides change. Now, what trig function can we use that's being modeled by this data? So for me, I'm going to focus on from my highest point to my lowest point here. If we have sine or cosine, let's just look at cosine here. The highest point to the lowest point is always going to be half a period. So the high to low is always half a period. So I am going to go ahead and set up a cosine function since that's the closest model to this data. So part A, if I'm going to create a trig model, I need to first find its amplitude, and it doesn't matter whether it's sine or cosine. The amplitude will be the same. That's my highest y value minus my lowest y value divided by 2. So that's going to be 11.3. That's my highest. Minus 0.1. That's my lowest divided by 2. So this is 5.6, which is A. This is calculator active. So now I'm going to look for my vertical shift. Now notice that is always going to be the same for sine or cosine. That's high plus low divided by 2. 11.3 plus 0.1 divided by 2 is 5.7. So that's D. So the middle is somewhere around here at 5.7. Next thing I need to find is my period. So my period is always going to be double the difference between where the x value or time value from where my highest and lowest are. So we can see this distance here is 6, and that's just the difference between these two x values. So this is half. So let me mark this better. The difference is always 1/2 a period. So it's 2 times their distance difference, and I'm going to say the absolute value of their distance difference. So that's 2 times 6, which is 12. So that means if my period is 12, that's 2 pi over b. So b equals 2 pi over 12, or pi over 6. Now, where I start here at my highest value, that shows me that I am shifting right 4 units. So that tells us that C equals 4. So now I can set up my cosine function, and I'm going to make it a function f of, I'm going to say f of t, because it's a function of time, is something to do with cosine. So my amplitude is 5.6, and then I have pi over 6 for my b. Since I'm shifted right 4, x minus 4, and I'm shifting up 5.7. So this cosine function represents that model. So now we're going to use our calculator to do part B. And one thing I want to point out is, since we're using radians, make sure your calc is in radians. So the first thing I'm going to do, since I'm using my calculator, is I am going to store my function. And remember, we do that by saying f of x, and then you press this special button, right? This button right here, that makes us store the function. And I'm going to store in 5.6 cosine of pi over 6. Oops, let me move this over. Times x minus 4 plus 5.7. So remember, t equals 0 corresponds to midnight. So that means 9 a.m. means that t equals 9. After I've stored my function, now I can just find f of 9, which is approximately 0.850 feet deep at 9 a.m. I'm going to let you use your calculators for this. So my next time is 3 p.m. That is 15 hours after midnight. So f of 15 is approximately 10.549 feet deep at 3 p.m.